Hello everyone, I'm Larry from Fix. Today we come to learn the lesson of A13 CPU. First, look at the schematic. This is the CPU of iPhone 11. In this schematic, the new model, this one has no model label. There is no model and line marked on it. What to do in this situation? In fact, they are all in one principle. We just need to click this schematic, click this CPU. For example, in this line, then measure this. In the middle of the point in CPU, there are lines with a lot of pins. For example, this line, then measure this. If it is this line, just test here. Anyway, click these power supply pins. These are the power supply pins in the middle. These points in the middle are composed of only a few lines, so the schematic are temporarily imperfect. You need to measure the quality of the CPU. Click the middle point directly. Then look at the point next to it. Measure whether it is short circuit. It is normal if there is no short circuit. Next, switch back to my operation screen. Next, look at this iPhone 11. This is a locked iPhone 11. Because our course uses an ID board. Next, start to handle it. Take out our PCB holder, layering it first. Same as the previous iPhone X. First, layer it. Temperature 320, wind speed 30, layer it. Hot air gun without nozzle. Move your hand to blow. Not melted yet. Continue to blow. Tweezers are tested here. They can be inserted if they melt. We can pick it up. Then finish the layering. Clean the thermal paste on it. Like this A13 CPU is surrounded by small capacitors and small resistors. You have no suitable entrance for prying. Resistance, capacitance, this a lot. No suitable place. Let's look at the schematic first. But actually, in this row, all are 1N GND and 1N connect the line. But this one is 2N connect the lines. 1N GND. These are all capacitors, suitable for inserting the blade. You can observe these colors. Yellow is basically a capacitor. 1N GND is a capacitor. So remove this 1N GND capacitor have no effect. But these black one, a large row of black here, a large row of black here, this is definitely useful. So you can't enter from these places. You can only be used as an entrance in a row of capacitors. It doesn't matter if these are lost. As mentioned in the previous course, if this capacitor is grounded and connected to the line, remove it, that has no effect on the circuit. So choose these places as the entrance. Next, start to remove the edge glue. Install the air gun nozzle. In addition to the edge glue, a 6mm air gun nozzle is used. Remove this side glue. A13 glue is relatively soft compared to A11 and A10. It will be easier to handle. Treat these side glues. There is nothing to say about this side glue. Because the edge glue of each model is basically the same method. There are many small resistors next to A13, so be careful. Try not to touch these small resistors. Missing one may be the cause of failure. Be sure to check carefully. This small resistance cannot be lost. After removing the edge glue, through the conclusion just now, you can determine the entrance. We are going to insert the blade here. The position where two capacitors are needed for the blade like this. We can remove the two capacitors. Remove the two capacitors at the position of the blade. This row is full of capacitors. Like this black one, it must be distinguished from yellow. This black one must be not dropped. We can remove yellow one like this. We can remove one more. 3 capacitor positions are enough. Next, start to pry the CPU. This A13 here, A13, its PMU is next to the CPU. So it is the same principle as A11 and A12. Cannot blow without nozzle, only with small nozzle. Only in this way can let the PMU be better protected. Or find a shield cover. For safety, this plate can be blocked. This will be better protect the PMU. Okay, then start to pry the CPU. Temperature 390, wind speed 40. This is the cutting point just now. Adjust it. Okay, first, rotary hitting the CPU. Here is a 6mm nozzle. Rotate and blow like this. The air gun is placed vertically. Put the blade at this entrance just now and wait for it to melt. Wait for it to melt. As oblique as possible. This will ensure that you shovel to the bottom of the CPU. Wait for it to melt and see when it can be inserted. At this time, don't use force. Wait for it to melt before inserting. Find the feeling of the blade can insert a little bit. At this time, tin must have not melted, and I have to blow it again. Tin melted and inserted is very simple. It hasn't melted yet. You have to wait. Keep blowing. The blade is waiting here. Heat evenly around. After inserting it a little, insert it inside more. This time you can insert a little. Now ready to insert. The blade should have a slanting feel and a bit upward force. Okay, it is open at this time. Note that you should blow the back of the CPU in front of where we are going to insert the blade. Okay, so that it can pry down. I just inserted it first when I pried it. Then it takes a little effort to lift the CPU. Insert like this, lift it like this, lift it up. Lift it up and remove it, so that the CPU can be removed. Next, take a look at the CPU, just remove it. See if there is any drop points. Recall how we pried it down just now. First, remove the 3 capacitors in the middle. Then plug into the position. After tin melts, insert into this position. After tin melts, pry up like this. Open the CPU like it. We can lift the CPU like this and put it aside. Next, put the CPU aside. Handle the part while it is hot. First, add some 183 tin to mix. the small color head of the soldering iron. Quick 1200, temperature is 350. But in fact, the temperature of the soldering iron, if this tin can be melted, the temperature of the soldering iron is enough. If the temperature is not enough, increase it. If the temperature is high, decrease it. Just melt is enough, as long as the tin can be melted. So the temperature of the soldering iron is not particular. You need to make your own judgment based on the scenes. Then we change all these tins. After these tins are replaced, clean the soldering iron. Use a small cover head to shower off the glue. Then we will roughly go around. After that, we will process it with a blade. Next, use the 11 blade. Use the tip of the blade to remove the edge glue. Temperature 320, wind speed 30. We need to remove these glues. Be careful of this black resistor when removing the edge glue. Cannot missing them, they are all useful. It doesn't matter if this capacitor is slanted. This one has touched when the blade encountered it. This row is full of capacitors. When dealing with edge glue, use the tip of the blade when the glue near capacitor, because it is more easier to remove the glue. but the tip of the blade is sharp, so be careful not to scratch the layer. But when processing the middle of the pad, the back part of the blade with a number 11 blade is used for processing. Finish the edge glue and apply thin again. The reason is if there is glue cover around, there is no way to change the thin. Replace the surrounding thin again, only after it has changed. After ensuring that every point is got the 183 tane, you can flatten the pad. Be sure to use a cover head. If there is no cover head, you can also be careful and remove it slowly. The blade is flat, basically very safe. There is no risk. Other soldering iron tips, such as if not flat iron tip, be careful when removing glue, not too fast. Because the contact surface of the small cover head is flat, it can be faster when the edge glue is removing and flattening it. When close to small capacitors and small resistors, be careful not to hit the small components too hard to avoid problems. The loss of small components may be the cause of the failure to install the CPU. In many cases, the welding is done. Then check the small part around. If you encounter strain current after installing the CPU or show you a flash error, then it is important to check whether the small components are damaged or missing. Clean after dragging. Dip the cotton balls into the washing water and wash it here. After cleaning, check the surrounding glue for scraping. If not scraped, you need to continue processing. In the process of processing the CPU, the details are very important. After row cleaning, be sure to check around. For example, here comes a tin ball. You have to take it off. Don't let small details cause failure. Check the glue around again. There is still a bit of glue left here. Take it off. This little bit of glue doesn't need the hot air gun. Use a blade to scrape it off. Then deal with it here. This time we deal with the back of the blade. This side of the blade. Then remove the glue on the glass IC. This is not too clean, just roughly. I am afraid it will hit the solder joint, so just smooth it out. Clean again. After cleaning, at this time check if there is any drop. These are NC pins. Remember to check before loading. Next, deal with the CPU. First, scrape the glue around the CPU. To cut it off. Then hold it with the PCB holder. Add some tin. Let's mix this tin with original tin. Do not use force during this process, because now only the tin is changing on the surface. Do not remove it with a soldering iron in this step. It is very dangerous to remove the glue with a soldering iron on the CPU, may cause dropping points. So don't think about removing the glue here with a soldering iron. After the removal, at this time, after replacing the tin, use a soft blade to scrape the glue. such a big soft blade. Air gun temperature 320, wind speed 30. Clamp the blade. Then we first observe the soldering joint above. When it shines, it is time to get the blade. See if it is melted. It is time for us to get the blade. After melting these places, we can clean the glue. These solder joints melt where the reflection is shiny. These solder joints can be removed directly on it. Then we start to divide from 4 sides. The middle can be processed later. The glue on all sides must wait for it to melt before removing. If it is removed without melting, it will cause basically drop points. After finishing this side, we will change the side. Treat it this side too. Hold it here. Then blow. We can remove it after melting thin. If you use this method, clean the CPU glue is very simple. The glue can be removed in less than 30 seconds. If you are skilled, you can remove the glue faster. You don't have to worry about the glue around. This is the effect of our glue removal. After finishing, add thin again. Let every solder joint get the 183-degree thin. At this time, every solder joint is welded. Use this solder wick. Cut into a few sections. Use tweezers to hold this solder wick. Clamp like this. Then go to flatten the CPU solder joint. In the process of leveling, you can also clean the small part of the glue. Slowly flatten this solder joint. Try to make the side where the solder wick is in contact with the chip parallel. The larger the contact surface, the faster the speed of removing glue and tin. The contact surface is parallel to the chip, so parallel operation will be very smooth. Replace it immediately after using it. Cut 4 small parts here for backup. You can see the process of flattening. This little glue will also be taken away with the tin. Now it is almost done. Look at the first shot. Basically cleaning up. Then wash again. When washing it during hot, it is not harmful to the chip and the motherboard. You can clean it with confidence because it is not in power on state. This is harmless and it can help you to cool down quickly. This is a very safe method. The CPU can be used after washing it in the water for 2 hours. These cheap motherboards are completely waterproof, don't worry. It doesn't matter as long as it is not powering on. This time the CPU is handled. If you see little glues on these places, we must get rid of it in time. After removing it with tweezers, wash it again. These little details. At this time, we have cleaned it. We can plant in. Fold the paper towel twice. Fold in half again, so that's it. Then put the CPU. Ready to plant tin net. Before using the tin plant net, be sure to clean the dirt inside. Cleaning. Then use your finger to eject the moisture and debris inside. Although the steel mesh will not be damaged by fingers, but don't use too much force. But if you drop hard, it may be bad. Then we take a look at this position. There is glass core underneath. These little glasses can help us to get in position. So the alignment is very easy. The stencil is a little bit oblique here. We have to align the stencil. Use these curved tweezers to press here. Then take out the solder paste to be used. You can start soldering. Wherever you plant, use tweezer to hold it, so that it won't be drummed. Wherever you plant, use tweezer to hold it. For example, to add tin here, the tweezer must move down. If you add tin a little behind, the tweezer will move back. Everyone must remember to absorb the moisture of tin when applying tin. Otherwise, too much flux will cause a lot of bubbles when heated. After adding tin, use a paper towel or dust-free cloth to clean the residual tin on it. It is best to use a dust-free cloth, like this position, because I wipe it with a paper towel, the tin inside was soaked away, so we have to make it up again. It is better to use a dust-free cloth, the effect is better. because I use a tissue to suck the tin out of the hole. So we need to make up a little tin. Wipe it with a dust-free cloth. Using a dust-free cloth works very well. The tin in each hole is very uniform. Temperature 320, wind speed 30. First, heat evenly around. Then the twister follow the air gun in a triangle. The nozzle is following the melt place. Blow up a little. Check if there is any unplanted. If not, we can take it off. If tin is not planted after taking it like this, for example, it is not planted here. If there is a little hairball on it, put it back on the planting tin net after cleaning it. This method can be used in any situation of reball. This situation is very common, so we must pay attention to details. First, I like the approximate position. Points that are not welded like this are different from others. The bow is different from the others. So how do we deal with it at this time? Add some flux first. Use the tweezers, press here. The air gun blows. When it melts, it will fall thin after melting. If you can't blow it, you can poke it with tweezers. Blow after you poke. So that we welded it perfectly. After the tin is dry, take the stencil. This time it was planted. Then add some flux to reset it. Here is a thread here to take it away. Pay attention to details, otherwise it will cause failure. We reset. This time it has been finished the reball. It can be installed, but you can first check the resistance of these capacitors before install. Although the schematic are not marked with symbols, points. But we can measure this capacitor next to it. The red pen is grounded and the black pen is measured. This one have value. This end is grounded. This kind of capacitance. Grounded, have value. Have value, grounded. Have value, grounded. Like these places where we pry. Have value. Grounded. This must be a capacitor. Have value at one end, have value at one end, and grounded at the other end. These are all capacitors and can be removed. By the way, all of the nearby capacitors will be measured. Test to see if there is short circuit. If not, you can install it. Because the iPhone 11 power button is on the lower level, so on other models, after handling the pad, look at the current. But iPhone 11 power button is on the lower layer, so we can't see the current. So we install it directly. Clean the pad before installing. Apply a thin layer of rosin after cleaning. After finishing rosin, melt rosin. Blowing. Then add some flux around. Such solderability is better. The roll of rosin can help you fix the CPU, because rosin is sticky. Flux is more flexible. So if you install CPU, it may float, but if you add rosin, it will be more stable. Then correct the position of this glass core. Then cover it back and set it right. Adjust the gap around. This gap is very good, because there is more resistance next to it. Just align it evenly. Air gun temperature 380, wind speed 30, put it back. Wait for it to melt and put it back. First, wait for it to bubble. At this time, the bubbles start to burst. Bubbles pop up. This is a reset action. Then we push it slightly. It will bounce back to its original position. Proof that the CPU is already installed well. Wait for it to dissipate. Supplementary explanation here is to reset so many times, just for demonstration. You only need to reset it once. The reset process is to see bubbles appears. Wait for a while. it will have a pulling action. We'll pull the CPU to a certain position. So back and forth. Then you can use tweezers to touch it lightly. Gently. Touch it lightly. It has a rebound action to come back to the original position. Proof that the resetting process has been completed. This CPU is already installed. Wait for the motherboard to cool down. Then this stencil we use now. The nets we use are the most common. Press all by yourself when planting tin. There will be more accidents like this. You can buy a tin planting station. Magnetize it underneath magnetic. Can help you fix this position. In this way, planting tin can basically not go wrong. This method of planting tin is relatively safe. The method of stencil net is more suitable for the public. The advantages are cheap, convenient and practical. Using the planting tin station is relatively simple and the success rate is high, but the cost price will be a little higher. Okay, let's measure after the heat dissipation. After the heat dissipation is good, go to measure if there is any problem near the CPU. Pick these yellow capacitors to measure. .13 is a low voltage line, not a short circuit. Here is also 0.11, not a short circuit. Let's pick the approximate capacitance to measure. How to judge both ends of the capacitor. Grounded and resistant at one end. This must be normal. These all have value. Next, we go to test. Because the power button is on the lower level, so we need to use tape plug for a boot. Then we install this. Switch the lens. Bright screen. Okay. Then our A13 CPU lesson is completed. The next lesson is the lesson about remove the A10 RAM without CNC. The disassembly and assembly of the A10 RAM is done with a blade. This is needed only without CNC. If there is no CNC, how to remove the A10 RAM? The RAM of A10, A11, A12, A13 is basically the same method of disassembly and assembly. After learning the A10 RAM, the other model also same. how to judge the quality of the RAM. See how to measure the current of the RAM. We will talk about it in the next lesson. Let us look forward to the next A10 RAM course. Bye.